going to try and talk to the whole room at once here. It's kind of a big crowd, so I'll do my best. My name is Jeff Yankellow. I work for King Arthur Flour and chairman of the board of the Guild. So I want to welcome you to Chicago and WheatStalk. This is the unofficial first event of the whole program, so thank you for coming. I hope you have a good time. So this class is about Baker's percents. It's just a review or an introduction, depending on how many people know it. What I wanted to do first is, in addition to welcoming you to WheatStalk, just encourage you all to, while you're here the next few days, there'll be more official welcome tomorrow, but talk to the people next to you, across the room. Don't just come thinking that you're only here for the classes, but remember that being here with the people who care much about baking as you do is just as important, if not more important, than the classes themselves. So there's a lot of collective energy here, a lot of people really passionate about what's going on, and that's something not to overlook. So the goal is, when you walk out of this class, first, how many of you use Baker's percents right now? Okay, so quite a few of you. Anyone have no clue what it is, or has tried it and just couldn't get a hold of it, understand it? Anyone brave enough to admit that? No? Okay. So my goal at the end of this class, I can't teach you in 45 minutes. I can teach you about Baker's percents, but I can't guarantee that you're going to walk out of here and be able to write formulas and have a complete understanding of it. But what my goal is to answer any specific questions you may have, and at least give you an introduction so that when you go out to these classes tomorrow and the next 2 days, 3 days, that you're going to see these formulas in Baker's percents and you have a good understanding of what it is that you're looking at. And when instructors may reference something in Baker's percents, you know what they're talking about. So Baker's percents is just a language, if you look at it simply. So it's a few things. It's a language. It's a way we talk about baking that helps us understand a formula, regardless of the batch size, regardless of how many loaves you're trying to make. But essentially, gives you an idea of what type of bread you're making. So it's a language to start. It's math, so it does involve some calculations and some math if you want to use it at a higher level. And then it's also a tool that we can use to troubleshoot formulas. And then once you take your experience with baking and combine it with Baker's percents, it becomes a tool that you can use to develop formulas from scratch. So we're at this point, maybe in your baking career, you look at recipes in a book, or formulas as we call them, you go home, you make them. That's all great, but maybe you want to start making your own. Baker's percents is something that can allow you to do that. Also, you may look at someone else's formulas and it's only in weights. By converting it to Baker's percents, it can give you a very clear picture of what style of bread that's going to be without going and making it. So there's some different things we know, and these things we know because we've learned about bread in other ways. So how much water do we need to make a ciabatta or a rustic style bread? Or how much water do we need to make baguettes? Or how much water do we need to make hamburger buns? All those things aren't necessarily Baker's percents, but we use that knowledge and apply it to Baker's percents to come up with formulas to make the type of bread we want to make. So hopefully that's a pretty simple concept. But basically, I'm just going to use some very basic formulas today, some very basic numbers to introduce you to the concept and make sure we're all on the same page. So we'll just do like a basic baguette formula. And we'll start with, we'll work with 100 because it's a lot easier. It doesn't matter if you're using pounds or metric or imperial pounds or ounces or kilos, but it's definitely much easier if you work in decimals versus fractions. I'm just going to write a simple formula and then we'll talk about it. Yeah. I'll do pounds, kilos, the same. Okay, so just starting at Baker's percents, if I put a formula like this on the board, it should mean something to you if you, in a sense, if you know Baker's percents, because in Baker's percents, everything is based on 100. So whether we're talking about percents or weights, everything all of these numbers are based on the flour. Okay? So flour is always the king. Flour is like the base of the recipe. If you're cooking something like a chicken soup or a stew or a roast or something, it's the same thing. Like how much salt, how much pepper, how much garnish you use is all based on how much meat you have, right? In bread, the meat is, or the flour really is the meat, okay? So when we look at this formula, we look at how much flour we have. What we're saying here is when we have 100 pounds of flour, this is how much of other ingredients we need to make this style of bread. And this style of bread is very basic, would make a very simple baguette formula. So for 100 pounds of flour, 68 pounds of water, 2 pounds of salt, 1.5 pounds of yeast. That would make a baguette with, let's say, an hour of fermentation. Okay, so well, that's easy looking at weights. How do we know what the percents are? What are we asking ourselves? Well, percents are parts of 100, right? So this is a part which can be a little tricky to teach because if you don't know math or you don't like math, this is basically algebra in a sense. We're kind of setting up equations and ratios and trying to figure out what the missing numbers are. So the first thing we would do if we get a formula like this, when someone sends me a formula and they ask me if I can help them troubleshoot it, the first thing I do is I have to put it in Baker's percents, because rarely is it based on 100 pounds of flour. So by putting it into Baker's percents, it allows us to look at a formula, and it doesn't matter how much flour you're using, because it's more of a trying to get a more of an understanding of the foundation of the formula, the workings of the formula. So what you're asking yourself is how many parts of 100 each one of these ingredients are. So does that make sense so far? Anyone have any questions? Or got it? Pretty good? Okay. So if you were to talk that out and work it into like a math equation, you're basically saying 100 is equal to how many percent? Which is 0.01 of 100. Okay, so you're asking yourself, how many percent of 100 is 100? Now that's obviously an easy one, because there's only one type of flour. So when you do the math, your goal here is basically, you're isolating the x. So you have to get a, so what you're saying is 100 divided by 100 times 0.01, or 100 divided by 100%. On a calculator, that's how you do it. Okay? So for each one of these, you're basically saying 100 is equal to 0.01 of 100 because it's 100 pounds. And then you have 68 is equal to 0.01. 2 is equal to 0.01 of 100. And 1.5. So if you were to do all this math, basically you're saying 100 is divided by 100%. 68 divided by 100%. 2 divided by 100%. 1.5 divided by 100%. And when you get those numbers, because this is a very easily formula based on 100, to make it easy, it's basically going to come out to exactly like it is in the formula. So now what we can do at this point, why is that helpful? Because now if we get rid of this, then what it does is, for one, it allows us to tweak this formula to understand it a little more. So we know, see in the US we have some, we kind of know like a range of hydration, what type of bread it's going to get us. So that's the part where I say some experience related to Baker's percents allows you to really use this as a useful tool. So if you're working in the 55 to let's say 60% water range, what kind of bread is that going to make us? It's going to make us firmer dough, more fluffy texture, maybe more denser, like bagels on the low end, pretzels on the low end, ham breads, maybe hamburger buns, closer to 60%, 62. If our water is more like 65 to 68% probably like traditional French baguette. If we're looking a little higher, like 70 to 75 or even higher, more rustic breads, more loose structures, more rustic shapes, more irregular whole structures. So right away when we look at this formula, if I didn't tell you this was a baguette formula just by looking at 68%, then I know that this is probably in the baguette range, kind of a medium soft dough for American style flour, white flour. Salt 2%, so salt is basically very general in bakeries. Usually we're going to use 1.8 to 2% salt. Salt regulates fermentation. It helps make the dough easier to handle. It also enhances flavor. If you forget the salt in your bread, it's a mistake you won't ever want to make again. It really makes a huge difference. And then yeast is just a matter of fermentation. So how much yeast we have will tell us what our fermentation time is. And what our fermentation time is related, again, to what type of bread we're making. So usually quicker fermentation times means we usually have less water. We develop the dough more in the mixing bowl. Longer fermentation times usually we're using looser doughs, developing the dough more through fermentation, longer fermentation and folds. So why it's good to look at this, because I can take this formula and then by knowing the percents, it allows me to understand what it is. It allows me to talk to another baker and find out what my formula is compared to theirs. So if I say, hey, what's your baguette? And you tell me, how much water do you have in your baguette? And you say, 8.3 pounds. It means absolutely nothing, right? But if you say 70%, then I know, well, that's on the softer end, or what's your fermentation? It gives me a much better idea of what type of bread you're making. Or if you say, well, we're having some trouble with our baguette, we ferment it for 3 hours, and I say, I'm going to ask, well, how much yeast do you have? A weight would mean nothing, but if you say, oh, we have 3% yeast, then right away I'm like, 3% yeast and you're fermenting it for that long, you've got a problem, right? So at a very basic level, these are the tools that really help us with baker's percents. So as we expand a little bit, that's the very basic, like step number 1. Basic concept. Flour is the king. Everything's based on flour. Flour is always 100. Everything else is based off of that, okay? So now the next step would be, what if we have 2 flours? That's a pretty simple next step, but a very important one anyway. So let's say we have flour 1 and flour 2. So white flour and whole wheat, white flour rye. The percentage is split between the 2, right? Hopefully everyone who's used baker's percents knows this. So whether it's 70-30 or, let's move this over, 50-50 or 70-30 or 25 and 75. Flour always adds up to 100, right? So then everything else is based on the total weight of those 2 flours. Okay, so that simple concept there too. I'd say that's maybe the next stage, but still very basic. So most of the formulas that you're going to use these next 3 days are going to be set up in the Guild standard format, which most of you may know already, probably. If you go to the Guild website, there's a very long explanation. There's a link on there. It explains, it links to the article that was written a few years ago on the baker's formulas, the baker's format, bread baker's Guild format, or formulas. So this is what I just want to say. The format, it is baker's percents, but it's not. What happened was the Guild was teaching all these classes. We have all these instructors. Most of them are volunteers. We get these formulas in all different formats. Some in baker's percents, some not, some in pounds, some in kilos, some in grams. So what we decided to do was develop a format that was just allowed us to give out the formulas always the same, no matter who they came from. So we're not saying you have to use this, it's the best in the world, or it's the only way. It's more of a format, but that format uses baker's percents, and if you go to the website, there's an article on baker's percents, and there's an article on that format itself, which also talks about baker's percents. Okay, so the next thing we're going to do, most of these formulas, some will be straight dough, what we call straight dough, which means you take everything all of the ingredients measured on the table, you put them in the bowl and mix your dough, ferment it, make your bread. But most of the formulas you're going to use probably in the next day, 3 days, you're going to have pre-ferments, right? So pre-ferment is this idea of taking some of the flour, some of the yeast or natural starter, some of the salt, and then pre-fermenting that, meaning fermenting it for any determined amount of time before you mix the final dough the next day. What it allows us to do is develop flavor and characteristics of long fermentation, acidity, strength, without going on these extended periods of fermentation on the day we bake. So how do we use pre-ferments, how do we develop formulas, and how do they work? Well, usually what you're going to see is you're going to see 3 columns. So the first column will be the total formula. Then the next one will be a pre-ferment. Could be pre-fermented dough, poolish sponge, levain, and then the final dough. Okay, so each one of these are viewed as a different formula, let's say, in itself. Meaning some books out there may say the flour percent is equal to the percentage of the flour in the total and in the pre-ferment, meaning this is 80 and this is 20. But that's not how you want to look at it. Basically, you want to look at each one of these as a formula on its own, okay? So let's say using that same formula we had just for a simple baguette, just makes it a lot easier. And again, all of our formats is done in metric, in kilos.
I'm having a really difficult time seeing any of those numbers that you've just used with your pens and different.
Yeah, maybe it's.
I mean, I know that what they are because they were there before. Oh, there you go.
Is that better?
That's better, thank you.
Okay. I just gotta hold it a little broader. Okay, so something you're going to see in these formulas with pre-ferments, you're going to see a pre-ferment in the middle. Again, that can be old dough, which we call pre-fermented dough, pat fermente, poolish, sponge, viga, levain. It'll usually say percent of pre-fermented flour somewhere at the top here. So what that's saying is how much of this flour did we decide to put in the poolish or the sponge or the pre-fermented dough. I would always try and make clear, a lot of you guys have experience, but some people think that a poolish or a sponge is additional flour, additional water, additional yeast. Basically, if you were to put all these ingredients on a table, you would take whatever you want for your pre-ferment off of that table, mix it the night before, or 3 hours before, or 8 hours before. Leave it on the table, but already mixed, and then the next day, the whole table, everything on the table goes into the bowl. You're not taking something additional and adding it to the formula. Because in the end, we need it to be balanced, and the easiest way to balance the formula is in the total formula. Whatever starts in the formula is what ends up in the formula. So let's say we're going to work with a poolish, which is real traditional for a baguette. We would have flour, water, yeast. We would already determine what our formula is for that pre-ferment. And this is something that also comes down to experience. It's baker's math, but it's not at the same time. It has to do with having that experience and that idea of what is a traditional poolish? A poolish traditionally is flour, equal parts flour and water. What's a sponge? Generally it's 100% flour, 62% water. Pre-fermented dough, it's old baguette dough, so it could be basically exactly what's already up there. So that's just kind of, there's some on the web, I don't know which newsletter, but there's a newsletter I'm sure on the Guild website that talks about all the pre-ferments. Most of the baking books nowadays talk about it if you're not familiar with them. They all add different characteristics. But how do you determine how much flour to put in that pre-ferment? This also comes down to experience, a little bit of what type of bread, what style of bread, how much fermentation time you're able to give it. So sometimes people say, well, they like doughs that are always fermented 3 hours, or they like to retard them overnight. Well, sometimes we get into situations, especially in commercial bakeries, where we don't have time to do everything overnight, or 2 hours, or 3 hours, or 4 hours. Or if we're using machines, often we need to adjust. And by using higher levels of pre-ferment or lower levels of pre-ferment, we can then change our final fermentation to suit our schedule a little more without sacrificing flavor. Traditionally, a baguette wasn't actually made with poulish, wasn't fermented as, or they didn't think of the flour being fermented, they think more of the water. So 1/2 to 1/3 of the water was put in the poulish, and then an equal amount of flour. But usually the way we try and teach it, it's a lot easier for people to comprehend how much flour is in the poulish. And generally it could be anywhere from, I would say, 25, even 20% at the low end, all the way up to 40% at the high end. And when determining how much flour to put in there, remember this flour is going to ferment for about, let's say, 12 to 15 hours on average with this little bit of yeast. So that flour, we're going to develop a lot of flavor, we're going to develop acidity, but we're also going to degrade the flour a little bit. It's going to break down some. The more flour we have in that pre-ferment, the less fresh flour, so to speak, we have in the final dough. So it becomes a little more risky if this pre-ferment over-ferments or something goes wrong. The more we have in there, the more problems we can also have. But anyway, so how do you determine how much flour is going in the poulish? Well, let's just go with 20%. We'll just say 20% of the flour we're going to put in this poulish. So that means 20% of this flour right here. So 20 pounds, or 20 kilos. Once we get our flour for the pre-ferment, at this point, nothing else matters. So basically, we start with the total formula. That's all we're looking at to start. Now we're on the pre-ferment, which is going to be a poulish. That's all we need to look at right now. So basically, if we have 20 pounds of water or 20 kilos of water, we're going to have the same amount of, flour, we're going to have the same amount of water. And then the yeast, basically a general guide for yeast, if you want to go 12 to 15 hours in your poulish, you're going to use about 0.1% of fresh yeast. If you want to come down to maybe 7 to 8 hours, you're probably going to use about 0.7 or 0.8% fresh yeast. And if you want to go about 3 hours, you're going to use about 1.5% fresh yeast. So usually the longer it goes with the lower amount of yeast, the more flavor, the more complexity you develop. But sometimes there's different reasons to do shorter ones or longer ones. So sometimes, I worked in a bakery, we mixed the focaccia early with poulish that we made and let sit overnight. But the baguettes we didn't mix till 4 in the afternoon. But no one was there at 4 in the morning to make a poulish. So in the morning we make a fresh poulish with a little bit more yeast. And that's what we used in the baguettes.
Did you have to add yeast at the dough side to a 3 hour?
Because a lot of the yeast will be in the poulish, so you may not.
Okay.
Depending on how much yeast is in your. Sometimes all the yeast could be in the pre-ferment.
Are you adjusting your final proof?
Usually the final proof won't be too affected. The more pre-fermented flour you have, the more active your dough will be, and you may find you need to change the yeast. But where the yeast is, whether it's here or here is really what determines your final proof and your final fermentation. So it's total yeast that really determines your final fermentation and proof. What you're trying to do here is just get the benefits out of fermenting that flour. But sometimes you may make a formula and you find out that for whatever reason, when you change the pre-ferment, the dough is acting a little bit differently. And generally, it may be ready sooner, or maybe you want to adjust the yeast, or you take it a little sooner. But in general, we look to these numbers here to determine how long our fermentation and proofing will be. Okay, so now we have our pre-ferment, 0.1 of 20. If this was in metric, it'd be pretty easy, right? 0.2, right?
0.02.
20 grams, or 0.02 pounds. Okay, so then we move on to our final dough, and what we're basically doing is saying, what do we take out for the pre-ferment that needs to go in the mixing bowl the next day with the pre-ferment. So we have the same ingredients: flour, water, soft, yeast. And then we have one more, right, which is the poolish. So now at this point, we really don't have percents yet, anyway. What we're doing is we're working with just simple math, so weights, pounds, kilos. So we just go straight across. And this is what all these formulas will look a lot more neat than this. They'll be in grids and colors and stuff, but essentially what's happening is here you're subtracting that weight from this weight to get this. So anything that's in the pre-ferment will come out of the total formula, and what's left will end up in your formula here. So what do we have? 80, 68, 48, 48. And soft, we don't have any soft in the pre-ferment. And then yeast, we have 1.40, right? And then poolish, well, we got to add this up, so we have 40.02. Sometimes we'll put a little soft in the poolish, by the way, too, just to slow it down. If it's a really hot day, or for some reason it needs to go a little bit longer than we want it to, we may put 0.1 or 0.2% soft in the poolish. But if we did that, it comes out of the total formula. So this is what we call the final dough. Meaning tomorrow or whenever we go ahead and mix this final dough, this is all we really need to worry about. We don't even need to pay attention to the total formula or the poolish. And for me, at the mixing bowl, that's what I like to give the bakers, the guys mixing. So less confusion, here's the formula, less numbers to worry about. This is also a good place to check yourself. Because if you did everything right, this total should add up to the same total over here. So the final dough should always add up to the same quantity as the total formula. And if it doesn't, there's a mistake somewhere.
Yeah. Question here.
Yep.
The 0.1% on the yeast and poolish, you
Yeah.
said that's fresh yeast. You're
Right.
using dry yeast, and you still do 0.1%.
Yeah, so dry yeast, okay, so we have active dry and we have instant dry, really. So active dry, in theory, we use 50% of the weight of fresh. I'm not a big fan of active dry because usually you have to, it's an additional step of rehydrating, although what I've been told is it's now formulated in a way that you don't have to do that. But instant yeast, we say, well, they recommend 1/3 the weight of fresh yeast. From an artisan baking perspective, I've always done 40% of the weight. Because usually 1/3, they're talking about really high production bakeries, commercial bakeries, dough temperatures in the 80s, 81, 82. So for what I've always been taught from some guys at the SAF is we use 40% when we're doing artisan bread. And the difference in weight is water. So if you have 10 pounds of fresh yeast and you change it to 5 pounds of active dry, what you took out was 5 pounds of water. So in theory, you need to add that water back. But anyway, so when it comes to add little bits like 0.1%, I always use the same, whether it's fresh or dry. I never go less than 0.1. So when would I go less than 0.1? If my environment was super hot, like I really had no control. But even then, I'd probably do salt first. But I almost never go less than 0.1, especially if it's a really small amount of poolish, which in bakeries you're probably not doing. But very small amounts. At one point, there's almost no yeast to put in there if you go too low. So, but at higher amounts, I do convert it and use less.
So adding salt, how much would, like a pinch?
I would start with
You're-
like 0.2% is
Yeah,
usually where I start.
okay.
Yeah. I've seen as high as 0.5. I don't think the flavor is quite as complex, even with a little bit of salt, but you have to balance the risk with reward. So,
Gotcha.
0.2% and everything's good and the final dough is good, or, maybe a little less complex, or no salt and it's kind of a wall, who knows what it's going to look like in the morning.
So in the formulas, we can always assume that it's fresh yeast?
It should list it. It should list fresh or instant yeast. Most people nowadays, I mean, I think fresh responds a little quicker because it's not as dormant as a dry yeast. But in general, I think the instant yeast is a lot of people find it's a lot more convenient. You can buy a case and leave it on. You don't have to worry about it ever going bad. Some regions it's hard to get fresh yeast, so it could be 2 weeks old when it comes in the door. It could be 3 weeks old, and so it should indicate for sure. I think our formulas all say what it is, right? Fresh or instant. I would never assume, but that does bring up a good point, which is once you get a little more experience with baking and you know baker's percents, you could look at a formula and you could say 1.5%, and then it says 1 hour fermentation. You're pretty much going to know it's going to be. I mean, hopefully it will be fresh, because if that was instant yeast and there's no sugar or anything in there slowing down that yeast, that would be like that's a lot of yeast for the fermentation, you know what I'm saying? So when you know baker's percents, it's another tool for you to say, oh, well, it doesn't say, but it says, this much fermentation and this much yeast, so that would make more sense that it's fresh yeast or instant yeast or
What
something.
is the relationship between yeast and fermentation?
The relationship between yeast and fermentation, well, without it, there is none, I guess.
Right.
So you're talking about times?
As you increase.
Times are more or less, well, basically, so for me, I make more by feel and experience, things like that. So for me, basically, at 0.5, as a general guide, and knowing that there are many in-betweens here, at 0.5% of fresh yeast, for like a lean dough, let's say, water, salt, flour, water, salt, because at high quantities of sugar, we're slowing down. At low quantities of sugar, we may speed it up. At high quantities, we may slow it down. But like a lean dough, nothing really changing things so much or chemically. 0.5% yeast, about 3 hours of fermentation. Fresh yeast, 1%, about 2 hours. 1.5%, 1 hour. And then a lot of that will change. If you have a lot of pre-fermented flour, you may find that to go 2 hours, you only need, 0.5% of yeast. So the formula itself can also affect that, and the style of bread.
Is that for the poolish, not for the fermentation?
That would be for the fermentation.
That would be for the fermentation?
Yeah. So like some of the Team USA formulas you see, which are many pre-ferments, maybe up to 40% or 50% fermented flour, levains and sponges all in one. So maybe there's only 2 hours of fermentation, but if you there's probably less than 1% fresh yeast because they're so active. Maybe because they're softer, but at a very basic level. So walking before you run, like a general dough. If I wanted to make a ciabatta, which generally is what 72 to 82% water, 3 hours plus of fermentation, lots of folds. We're going to use 0.5% fresh yeast. That'll put everything else in balance. So the thing with baking is there's a lot of contradictions where sometimes something makes something strong and sometimes it makes too much of it makes it weak. So sometimes things tend to contradict themselves. But so for like a ciabatta with that level